Hello, my name is Dame Judith Hackett, and I'm delighted to welcome you all to this webinar for the launch of the Engineering X Safer Complex Systems case studies. I chair the Safer Complex Systems programme, which is part of Engineering X, and which is a joint endeavour between the Royal Academy of Engineering and Lloyd's Register Foundation. I want to cover off some important housekeeping points before we get into the meat of the webinar. The event is being recorded and will be later uploaded onto our website. Throughout this webinar, your camera will be off and your microphone will be muted. So only speakers and those giving presentations will be visible on the screen. Please use the Zoom chat to submit questions for the live panel Q&A later in the webinar. So bearing those important points of etiquette in mind, let us move on to the meat of what we are here to discuss today. I think it is clear to us all that our world is becoming increasingly complex and unpredictable. People rely on critical infrastructures to survive, to stay safe, and to maintain a good quality of life. But much of this infrastructure is made up of complex systems that are highly interconnected and interdependent on one another, and which are also constantly evolving, often without us noticing. It would be impossible for us to make a list of all of those complex systems that we rely on, but they're increasingly socio-technical. They include energy, food and water supply chains, healthcare, education, finance, housing, transportation, telecommunications, and data networks. The rapidly changing nature of the world we live in means that these complex systems operate in the presence of swiftly emerging technologies and unprecedented levels of global risk, and in ever greater levels of uncertainty and unpredictability. As the COVID-19 pandemic has demonstrated to us all only too well, complex infrastructure systems do not exist in isolation. Many other complex systems are also affected one by the other. The pandemic impact has extended far beyond the healthcare infrastructure and has had many and varied consequences for people's lives. So against this background of increasing complexity and uncertainty, in 2019, Engineering X launched a £5 million 5-year mission to enhance the safety of complex infrastructure systems globally. This Safer Complex Systems mission is guided by 3 distinct phases. Phase 1 is to learn from experts, to develop a better understanding of the landscape, and to identify where change is needed and who can help to make that happen. Phase 2 is to build a diverse community and to support them in knowledge sharing and collaboration so that they can be advocates for change. And in phase 3, it is about leading. For the engineering profession to lead as thought leaders and to engage with other professions and help to shape the global agenda on safer complex systems. Within and throughout these phases, we're focused on building capabilities aligned with 4 key themes. Theme 1 is to advocate. This aims to support researchers to spot emerging safety challenges and for professional engineers to spot systemic risk and advocate for mitigative measures. We believe this is important because stronger communication between engineers who see the risks at close quarters and senior leaders accountable for management will improve safety in complex systems and will help to save lives. Theme 2 is to educate. This aims to develop written case studies and innovative educational tools to support engineering education and professional development. This is important because increasing complexity and uncertainty means things get more difficult to predict, and we can no longer base the large part of our risk management approach on things that have already happened, extrapolated into future events. Theme 3 is about govern and governance. This aims to support innovative collaborations and experimental mechanisms to test new ideas for complexity and how to govern it, including appropriate policy and regulation. This is important because governance creates the framework within which a complex system is built and in which it operates. Poor policy and regulation can be a catalyst for contributing towards, rather than helping to prevent, systemic failure. Whereas good policy and good regulation, which is fit for purpose, will help to identify and mitigate system risks. Our fourth theme is about convening. As I said, we aim to build a diverse community. We want to facilitate knowledge sharing globally, and we want to support the transfer of academic knowledge into practice to enact change. The importance of this lies in the fact that different cultures internationally approach safety and risk management in very different ways. And we have to have an approach to this subject that recognizes that we can all learn from one another. To date, our work has focused mainly on learning and more recently on the building phases of this activity. Through numerous workshops, events, and engagements with hundreds of experts and community members, we've produced several reports already. The first of those was called Safer Complex Systems, an Initial Framework, also referred to by some as the York Report, because it was prepared by the University of York. This report establishes a state of knowledge and provides some recommendations which have informed our mission as we've taken it forward. We've also published Exploring the Safety of Supersized Structures. This report highlights the fact that few large structures exist simply as engineering structures, even though that is often how they are thought of, but rather most of them form part of complex socio-technical systems, and that needs to be taken into account in the way in which we think of them. We've also collected a lot of the learning from our numerous Safer Complex Systems workshops, and we've brought those together as reflections which highlight the need for a lexicon of safety, for formulation of acceptable levels of risk, and for foundations that will underline those key themes of our strategy. It has to be said that the Safer Complex Systems programme is in itself unusual and somewhat different from other programmes that certainly I have been involved with. We are continuously learning, we're challenging our own approaches, and we are adapting our activity plan as we go. We're particularly mindful of the importance of harnessing those diverse perspectives that I spoke about earlier. We're doing that by seeking input from people from different parts of the world, from different professions, different cultures, from different sectors, and people with different life experiences. So if you'd like to be involved with our activities, please do get in touch with our team and join our LinkedIn community of practice. One of the findings from our work to date is that case studies are widely used in MBAs and in the business environment to increase students' and professionals' understanding of key issues. But we do not believe that there is a convening point for a coherent library of case studies on the subject of complex systems. A challenge with complex systems is that they can be convoluted by feedback loops and ill-defined interactions involving individuals and organizations. A classic narrative form often doesn't capture the important points, and a new style of case study is likely needed, along with new and interactive ways of delivering them, and of ensuring that learning can move between very different sectors and different problems, because, as we've said, some of that learning is common. So to address this gap, we held a call for case studies in 2020 and funded the development of 18 unique case studies by awardees from academia and from industry. These case studies cover a very wide range of events. They range from train systems, collapse of school buildings and nuclear reactor leakage here in the UK, flood protection in the Netherlands, passenger ships capsizing in Belgium, systemic failures in nursing home care, as well as climate extremes, cyber-physical shortfalls, and transport network resilience in Australia, social innovator networks in Chile, intelligent dynamics of cycling systems in Colombia, fire risk management in South Africa, Bangladesh, and in the US, and global system failure, recovery, and emerging alternatives during COVID-19 in humanitarian supply chains. In examining these complex systems' successes and failures, and reflecting on the novel framework proposed in the York report, which I mentioned earlier, these case studies have provided insights into cross-cutting factors that may result in safe or unsafe outcomes, irrespective of the nature of the system itself. These include the prevalence of unverified assumptions, ill-defined boundaries of responsibility and accountability, and safety being seen as an engineering rather than a cultural or social issue. All of these are subjects which our panel will touch on later. In developing these case studies, our awardees have collaborated with various networks and have consulted expert mentors, which in turn has grown our Safer Complex Systems community even further. Now, by leveraging the lessons learned from these case studies, this work will inform the next steps in our program. So today, we're excited to launch this collection of 18 case studies. You can access the full collection at the Safer Complex Systems website, and you may also be interested to note that extended work from some of these case studies will be made available as separate reports and peer-reviewed publications in the coming weeks and months. These will be shared through our mailing list and the LinkedIn community of practice. This particular webinar today will showcase some of the work with presentations of 3 of those case studies, followed by a panel discussion of some themes observed across the collection. I remind you, please, to post your questions for the panel in the Q&A part of the chat function on this call. I do hope that you enjoy the event. I'm now going to hand over to 3 of our awardees to give us an overview of their case studies, and I hope you enjoy the rest of this webinar. Thank you.
Hi, I am Andres Medaglia, and on behalf of my co-authors, I'm going to introduce our case study that relates to temporary bike paths, an active transport system that emerged during the pandemic in our city, Bogota. But before I start, let me introduce myself. I'm a professor of industrial engineering at Universidad de los Andes in Bogota, Colombia. I have an experience of about 20 years in the field of operational research, mostly focused on developing and applying optimization techniques to problems arising in transportation and logistics, engineering design, agricultural systems, and healthy and sustainable cities. I have had the opportunity to serve in different journals and professional societies like the Institute for Operations Research and the Management Sciences and the Institute of Industrial and Systems Engineers. With my colleagues and students, we have been awarded several prizes, like the I-Force Prize for OR in Development, a work that shares roots with the subject matter of this case study. This talk is divided into 3 parts: context, the systems analytics methodology, and the learnings and transferability opportunities. Let's start with the context. Bogota, the capital of Colombia, is located in South America. With a population of about 8 million and an area comparable to London's, just roughly 10% larger, the city has a deep bike culture, and it is recognized for its wide bicycle infrastructure. In 2019, Bogota had 550 kilometers of permanent bike paths, with about 880,000 daily bike trips. Every week, on Sundays, the city closes 120 kilometers of its roads for the exclusive use of walkers, runners, rollerbladers, and cyclists. This event, called the Ciclovía Recreativa, has been replicated in other cities worldwide. On March of 2020, the Colombian government declared the country in a state of health and sanitary emergency due to the COVID-19 pandemic. Bogota, based on its existing bike culture and infrastructure and its Ciclovía Recreativa program, quickly deployed 84 kilometers of temporary bike paths over the city road network, connecting the existing infrastructure and mirroring the main public transport corridors. By June of 2021, 21 kilometers of the temporary bike paths were transformed into permanent bike paths. This case study presents the response of Bogota to the COVID-19 pandemic, which forced the city to increase its bicycle path network to accommodate a significant ramp in demand. Our aims are to describe the performance of Bogota's bicycle transport system and the measures taken to manage the COVID-19 pandemic, integrating complex systems modeling and data analytics. To evaluate the potential impact of policy decisions on the bicycle system in terms of safety, health, efficiency, and flexibility. And to provide evidence of the potential impact of an emerging transport system on preventing SARS-CoV-2 transmission. For the case study, we developed a systems analytics methodology to understand and assess the impact of the temporary bike paths on the system's performance. In this methodology, we integrated systems theory with data analytics, and let me show you how. Using a systems approach, we describe the system, set the study boundaries, and in a group model building workshop, we define the complex system and analyze its dynamics rules. The analytics approach collected and processed information to assess the performance of the system in terms of 3 main KPIs: collision rates, level of traffic stress, and physical activity. These data fed the agent-based model. The agent-based model evaluated different scenarios and helped us analyze the impact of the transformations related to the temporary bike paths. The output of this model supports the stakeholders' decision-making process to improve the bike system. After decisions are made and implemented, the system will be measured again, and we expect the cycle to continue. Let's continue by describing the system. Bogota's bicycle transport system produces interactions between bicycle users and other road agents who use the roads and the bicycle paths that connect the city. The actors interact based on rules for using that infrastructure and are externally regulated. These regulators modify both the infrastructure and the rules. Through its use and regulation, different stakeholders seek to satisfy the needs of bicycle users as a mode of transport and try to improve their conditions to generate more bike trips. For our case study, our baseline and follow-up years were the 2019 and 2020. We only considered bike trips for transport and not those for leisure. To understand the system's dynamics, we held a group model building workshop with 17 representatives of the system's actors. We went from selecting relevant variables for the system to developing a causal loop diagram. The diagram describes the variables in 6 main domains: civic culture, motivation for cycling, quality of life, substitute modes, citizen participation, and bike infrastructure. We identified many critical loops, like the connections between bicycle infrastructure connectivity, cycling time, and the increase in bike use. After understanding the different perspectives of the stakeholders, we described the system's complexity following the University of George's framework. One of the main causes of complexity is the system's evolution that relies on the interaction among bicycle users with the infrastructure and other road agents. The system adapts slowly, and competing objectives create an ever-increasing tension between motorized and alternative transport mode actors. 2 of the most critical possible systemic failures are an increase in collision rates among the bicycle users and a decrease in quality of life due to high levels of traffic stress, pollutants, and unsafe environments. The likelihood of a systemic failure can be reduced by programs that promote bicycle use and by operation time controls, like the creation of temporary bike paths. After describing the complexity of Bogota's bicycle transport system, we assessed the KPIs for the baseline and follow-up periods and implemented the agent-based model to analyze the impact of the bike paths on the system's performance. Let me share with you a brief sample of our results. The objective of the agent-based model is to recreate the use of the bicycle transport system, considering the baseline scenario in 2019, pre-pandemic, the follow-up scenario in 2020 with temporary bike paths, and a hypothetical scenario in 2020 without temporary bike paths. After estimating the level of traffic stress, we found a 4% increment in road segments classified with a low LTS. In the map, the low LTS is shown in green. The temporary bike paths may be responsible for this increment, as they reduce the speed and the number of lanes. As for the collision rates, the median collision rate decreased by 43%. Many of the areas where temporary bike paths were implemented show us a rate of 0 collisions, and these are depicted in green in the map. We estimated the health and economic value of the bicycle transport system of Bogota using the heat tool developed by the WHO. The analysis shows that in 2019, the prevented premature deaths were 199, with an economic value of 224 million euros. In 2020, due to the reduction of cyclists by the slowdown of the economy, the prevented premature deaths decreased by 26%. However, if not for the temporary bike paths, this reduction could have been as worse as 60%. After analyzing the results, we held a meeting with the stakeholders to gather their perspectives. At the meeting, staff from both the Planning Division and the Bicycle Management Division of the Mobility Secretariat discussed the study results and possible ways our study could support their decision making. They highlighted that the case study could be used to diagnose the system and the impact of the interventions, as it shows that the system is based on different social domains, which can support the development of social infrastructure in the city. The case study proved to be beneficial to support the city's mobility master plan and the land use master plan, where more bike paths will be built. Finally, the bicycle manager for Bogota stated that the case study supports discussions with local councils, brings academy closer to policy decisions, and improves Bogota's bicycle transport system. To conclude, let us touch upon some learnings and transferability keys from our case study. The case study shows the importance of the systems analytics perspective. This viewpoint integrates qualitative and quantitative analysis. This approach applies to other systems too, not just bicycle or transport systems. Transport systems need knowledge from all actors and decision makers to mitigate the risk of potential systemic failures. The transformation of the systems should consider multiple actors' perspectives and the interactions among them. Last, there should be a constant collaboration among actors, decision makers, and regulators to constantly improve the system, being the actors the leading promoters of feedback data from the system. We envision at least 3 domains where the systems analytics methodology presented in this case study could be applied to make other complex systems safer. First, to support reconstruction and mitigation strategies of interconnected infrastructure networks like gas, power, water, communications, and transportation. Second, to support investment decisions towards resilient bridge systems at a national scale, bringing together safety, natural risks, transportation disruptions, and socio-economic impact. Third and last, to prioritize interventions to make school facilities safer, especially those prone to earthquakes, floods, and landslides, like those in the global south. Working in this case study with our multidisciplinary team was a great experience. We are deeply grateful for the support received from the Royal Academy of Engineering and the Lloyd's Register Foundation through Engineering X and its Safer Complex Systems program. Finally, we would like to thank our mentors, John, Michela, Monica, and Thomas, who always provided us with timely, positive, and thorough feedback throughout the case study. Thank you all.
Hello, everyone. My name's Steve Gwynn, and today I'm going to be talking about wildfire evacuation as a complex system. On screen now, you can see the names of my fellow contributors to this project. I am a research lead at Movement Strategies, and I'm also industrial professor of evacuation and pedestrian dynamics at Lund University in Sweden. Before we proceed, it's probably useful to say what a wildfire actually is. And we can see here in this graphic an example. It involves the burning of vegetation in wildland areas, and then the movement of that via fire front or via firebrands. And we're particularly interested in those events that might then affect urban areas at the wildfire urban interface. Wildfires pose a serious threat to community safety. They're formed from many elements and that interact in complex ways, and these may be physical or social or environmental. The threat from wildfires is expanding and becoming more severe given climate change and environmental issues. And we can see in this map here where recent significant wildfire events were reported in the media. But why is this threat expanding? Well, existing communities are facing unfamiliar conditions as wildfire events become more severe. Wildfire events are affecting new locations. So new populations are being affected that were previously not affected. And again, that's reflected somewhat in the red marks on this map. And finally, people are moving in greater numbers to the wildland urban interface because of preferences in terms of being outside of busy cities and still having access to countryside. And these areas are again more likely to be affected going forward by wildfire threats. Now, because conditions are becoming more severe, the conditions faced during an incident are diverging from those historically seen. So it's harder to learn lessons from historical incidents and apply them to incidents that we might face going forward. To understand the threats posed requires us to understand the community's capacity to cope with the conditions faced. The objective here is to demonstrate the complexity of such systems and the challenges posed. Identify means to communicate the implications of these situations and support community design and planning. Now, wildfires have multiple domains, and these are highly coupled. These may be the fire itself, the attempts to mitigate those conditions and plan for them and intervene during an event, the residential response, and the traffic conditions that are produced during an evacuation from such an event. And these events interact to produce the engine for change, if you like, for the conditions that might be faced. Now, people might attempt to evacuate via several modes of movement: on foot, by car, by bus, and so on. And these responses are informed by information sharing, the information that's available and the perception and interpretation of that to build a picture and then decide what to do. Wildfire events occur over a larger area than might normally be the case, for instance, in a building fire, and may involve multiple locations because of the way in which wildfires travel and affect the vegetation present. They also involve multiple organizations and actors who intervene and respond over time. And it's the interactions between these actors and the factors that are present that change the conditions, and those conditions may be local or remote. So we have a system of many parts interacting over time that change conditions present at that particular location and remotely. Now, we can gain better insights by understanding these interactions and the aggregate conditions that might then be produced. Now, even more complex is the fact that these interactions occur at many levels. So if you look at the right-hand side of this diagram, you'll see an explanation for that. At the bottom there, you see an individual who is subject to information. That then affects their individual decision. But that individual may interact with others around them in a group or in who may be a social group, a familial group, or in a business or work setting. That may then affect the decisions that that group takes as they interact. Now, within a building, you may have many such groups who may or may not be familiar with each other. And so you have conditions evolving inside a building as people respond to the wildfire threat. In a community, you may have several buildings that are emptied during an emergency. And so you may have populations, residential or occupant populations from each building interact as they move to the next phase of the evacuation. Then that next phase may be entering vehicles that then enters the traffic system, initially locally and more widely. So you have individual actors processing information and then interacting with others around them at these many levels. So you have multiple levels of interaction affecting the conditions faced and eventually the outcome. Now that, of course, poses a number of different challenges, but it also poses a number of opportunities for those trying to mitigate the conditions and improve the response to intervene. So by providing information to an individual, by managing the evacuation from a building, or by managing the traffic as it moves to a position remote from the wildfire site. So from what we said previously, we have multiple interacting agents and actors and then external factors that do so at multiple levels. So we have a very layered, complex system where information is being shared and there is a local agency that affects the conditions that are produced. Now, in order to understand that, we did two things. We tried to map the evolution of conditions within an event, and then we explored this using a model to see the dynamics of how these conditions unfolded. We developed this storyboard process where we reviewed a range of recent incidents, compiled them to produce a hypothetical incident where we could chart the decisions that were made given the information available, and then map how this information flowed through the event, affected the response, and then what the consequences of the response might be. And we did this at multiple levels, at the populations level, the responders level, the government's response, be it local or national, and of course emergency responders, as well as the evolving fire conditions. And you can see examples of it here. I'll just focus on two of them. So firstly, we have three people here, person A, B, and C. The incident has started somewhere remote. Person A is just driving in their car. They're in traffic, but their radio's off and their mobile phone is out of battery. They don't know what's going on. Person B is at work. They've had emails and seen local social media about there being a fire, so they're aware of what's going on. And person C is in bed. They've not received any information, and so there's no threat perceived. Now, sometime later, person A may become aware of the incident by seeing smoke in the air, but they're stuck in traffic. There's not much they can do. Person B has left work, but then moves out of mobile range and then has to make decisions en route to a place of safety without new information. And person C has started to evacuate because they could hear their neighbours moving and decided to speak to them. Now, the point of this was to understand how people might make decisions, how those decisions might unfold, and then how those their actions might affect the conditions that they face and then their individual outcomes. It also was developed as a means to project this information and communicate it to a range of different audiences who may or may not have detailed understanding of this area, but may have an interest in the plans in place and the outcomes of such events. So the second thing that we did was to look at modeling a simple example to demonstrate how what might initially seem as superficially seem as a simple outcome may actually underneath have more complex dynamics. And we used an exercise that we observed several years ago, where a community, the Roxburgh community, conducted a drill. 133 households participated, and we surveyed them, and we captured data on when they evacuated, the routes that they used, and the time that they arrived, both from surveys and people on the ground making observations, to develop data sets that we could then use to configure our model to reflect the conditions that were produced. So here we have an example of what we did. We used our model, the Wunity model, which integrates the pedestrian and the traffic response and the environmental conditions inside a single simulation platform. We didn't look at the fire dynamics here. We just, in some scenarios, looked at the fire impact on the response. So what we first did was to say, well, okay, can our model approximate the data that we captured? And in the top left graph here, you can see that there's the drill results that we looked at, and this broadly approximated the original conditions. But then we said, well, what happens if the scenario was different? What happens if everyone in the community took part? And what happens if we lost a route? And we can see there that broadly, the final point of the conditions of the results rather look similar. So that the people evacuated broadly at approximately the same time. But if you dig down into the second graph here, you can see the speeds that were maintained across the event were different between the different scenarios. In particularly, when the full population was present, the speeds were typically lower than when either the original drill conditions were present or when a route was lost. Now, if we look at the third graph, we can see actually what the implications of that might be. And the red curve here shows the number of people that are still remaining inside the community space along the evacuation timeline. And what this shows is that more people were still in the community when the full community was present. And that means that if the wildfire conditions changed, they may have been subject, more people may have been subject to those severe conditions that might otherwise have been the case. So the point here is we can use these models that capture sufficient number of these factors to explore the underlying conditions and identify where the community is most vulnerable to the changing conditions and other scenarios. So why does this matter? Well, physical conditions are changing, social conditions are changing, and the outcomes of an event are not just simply dependent on the physical conditions present. Now, going forward, we may have regulators and practitioners who need a means of capturing these interactions, this complexity, in order both to understand community vulnerability, but then also to better inform the development of guidance and regulations. So ideally, you'd want a means to map out which communities are vulnerable given their exposure to wildfire conditions and the range of scenarios to which they may be present, and their capacity to evacuate, their capacity to get to a place of safety in sufficient time. Here we can see an example on the left here of the same community in blue, so a built-up community that has different road systems available to it. And you might then be able to say, well, what's the impact of those road systems on their capacity to get to a place of safety? Similarly, in the green community, how might it change if the community itself changes in demographics or age? Now, this understanding, this complexity, as we identified, means it's not possible to directly derive results. We have to have a means of modeling those results where they're not necessarily intuitive, but to draw insights from representing those interactions by the agents, the actors, and the factors present. We may need models that capture those interactions as we go forward to help us assess the effectiveness of designs, enhance guidance, and help communicate issues to interested parties along the timeline of a community, as shown in the diagram on the right. I hope this has been informative and interesting. Thanks very much for your time.
Hello everyone, I'm Kristen McCaskill and here today to give you an overview of our case study completed for the Safer Complex Systems program. Our study was on building transport resilience in light of climate extremes. And by resilience, I mean the ability to resist or absorb the effects of a shock or a stress, combined with the capacity to recover from an event that has interrupted a system. And I'd just like to recognise my colleagues Marlish and Catherine for leading this case study with me. The premise of our case is this, that infrastructure system resilience requires not just engineering design expertise, but also an understanding of our exposure to hazards, how that exposure is changing, and how the rules governing decisions determine certain outcomes. And we take a systems approach to the safety of transport. An earlier underpinning philosophy of road safety tended to be reductionist, solely attributing the fault of accidents to drivers, assuming that they were driving on an otherwise well-designed and controlled system. More recent approaches account for contributing factors in the wider road environment and considering a more systemic interplay of actions through vehicle manufacturing, law enforcement, land use, road design, and other users. Now, while systems thinking has been incorporated into transport safety in recent decades, this case takes the concept further. It adopts a socio-technical systems perspective that considers the criticality of the service provided. So community survivability is fundamentally linked to the transport or the ability of the transport connections to provide a working transport service. Now, extreme weather events can totally overwhelm the ability of the transport system to service communities. And our case explores the evolution of disaster risk governance capacity in Queensland, Australia, in response to a series of major flooding events over a decade. Queensland has a population of approximately 5 million people, and there's a high concentration in the southeast corner of the state, as you can see on this slide. Approximately 64% live in the mainly coastal cities and the rest in urban areas. The rest in rural areas across the state. And the state has over 183,000 kilometres of roads. Now, after a long period of drought, which is known as the Millennium Drought that lasted over a decade in the 2000s, flood events in 2010 and 11 overwhelmed the state and resulted in unprecedented damage, estimated at about 15.7 billion Australian dollars, which is approximately 8 billion British pounds. And the state was called into a state of emergency. And just by way of example, this is a satellite image of the city of Rockhampton. You can see that it's surrounded by floodwaters, and the Bruce Highway, which is pointed out to the south of this image, is completely inundated by floodwaters. And this highway forms the major transport spine connecting the cities on the coast. The reconstruction process that was required was extensive, and there was a capacity gap in overseeing this, particularly because post-disaster recovery invokes financial support from the national government, who stepped up to cover a significant proportion of the bill. So the Queensland Reconstruction Authority, or the QRA, was established in 2011. And the QRA was responsible, or was given the mandate, to distribute funds that were made available by the national and state government. And its task was to deliver this funding to local councils and the Department for Transport and Main Roads, who had assets in need of repair or reconstruction. And they were also given the mandate to provide the coordination and efficiency across this huge rebuild program. So the essence of our case is that it is not just about one safety incident, but how the governance system for recovering critical assets has evolved over the past 10 years as a result of the recognition to better manage the community safety in light of the exposure of communities to flood risk. Now, the QRA started out by managing reconstruction projects, focusing on repair and returning the road network to a condition that resembled something of its pre-disaster service or function. Now, if we think about this in terms of the scope of the system intervention, this was all about the repair of the physical infrastructure asset. And this was quite strictly driven by funding support that only allowed for like repairs. Another major flood in 2013 helped to pave the way for the Queensland Betterment Fund. And this added scope for the repairs to not only simply replace what existed before, but to improve the asset's robustness to flood damage. And the fund was comparatively small in size compared to the overall reconstruction bill, but it attracted a huge interest with projects from across the state applying. Now, when the QRA was set up in 2011, there was a sunset clause in the legislation, but further major flooding events continued, and in 2015, it became a permanent entity. This was the first permanent reconstruction authority in Australia. The betterment regime was becoming more established in the way that things were being done. And as a result, in this phase, we see a more formal recognition of the possible ongoing climate impacts, and that it is clearly not sensible to rebuild assets only for them to be washed away in the next flood. The QRA Act was further amended in 2019 to reflect the responsibilities for all hazards and to lead resilience and recovery policy. There was also an update to the underlying funding arrangements. So the disaster recovery funding arrangements, the DRFA, was introduced in 2018 to provide an opportunity for the reconstruction program savings to be spent on other preparedness and resilience building initiatives. So without getting into the detail here, essentially there were new incentives being introduced into the system, or new ways in which some of the available funding could be used. The QRA also became engaged in the development of resilience strategies and working with local councils, which included efforts in building community preparedness. So overall here, we see a transition from not just being an entity focused on repairing infrastructure, but one that is more broadly engaging with creating a safer outcome for communities. We adopt a version of Snowden and Byrne's Kinnovan framework to make sense of this changing remit and role of the QRA. So the Kinnovan framework is a descriptive framework, helpful in this case for describing the evolution of decision-making in Queensland over time. It describes five domains of decision-making, and the domains on the right-hand side represent more ordered situations than those on the left, which involve situations that require more sense-making. The sort of black hole of disorder in the middle represents confusion over what domain you're in, and that's not a good place to be in because it's difficult to know how you should go about making decisions. We applied a resilience lens to this framework, so thought about the types of decision-making or types of interventions with respect to resilience might occur in each of these domains, and then thought about the evolution of the QRA's actions over the past decade. So following an initial period of chaos in establishing the organisation during the response phase in 2011, we suggest that the organisation settled into something that could be classified more as a complicated operating basis. Expert engineering knowledge was necessary to develop solutions for the reconstruction, and the solutions were mainly technical interventions, for example, reinstating road pavements, perhaps adding rock protection or redesigning protection around bridges to help ensure they don't wash away in the next flood. So they were essentially building good practice, and in some cases perhaps moved into the simple domain and establishing some best practice. But over 10 years, the QRA's system of intervention has expanded to include wider considerations for the environment and communities. So this goes beyond the initial mandate for the recovery program coordination and involves a more complex operational context. It required different types of knowledge, and there wasn't always an obvious engineered solution to the problems, particularly not an obvious one that was affordable. Now, these developments were the result of repeated experience of flooding and the associated learning and capacity building that resulted from that. So if we step back from the detail of the case and think about the possible learning for people around the world who are responsible for critical infrastructure assets or making policy making and decision making at a city or regional level, I think there are a few lessons that we can draw out of this case. Firstly, the QRA not only created new processes to help manage a major reconstruction program, they also created a knowledge base that ensured the technical problems could be resolved to an appropriate standard in a more consistent way, because they built up a database of information and decisions which helped to streamline the process and build expertise in the system. They also added, as point 2, they also added density to the sort of social fabric of the system and linking national, state and local government. So they built a network that allowed the transfer of knowledge across these different levels of government. And they did this by building a network with the local communities early, and in the process was in parallel with their technical decision making. And this point is closely related to point 3, where there was evidence of managing tensions that arose for differing interests and priorities across these levels of government in the system. It was by no means perfect, and there were some criticisms of how things are working currently in our interviews, but there was also a lot of positivity around the benefits that these arrangements have brought to the state. And finally, in expanding its remit beyond the asset reconstruction program to engage with capacity building, the QRA sort of did that through evolution. So it wasn't in its mandate to do this, despite the added complexity that this brought to defining what success looked like for its own operations. And I think to do this, leaders need to be able to understand multiple points of view, and to pay close attention to stakeholders and be more invested in solving problems than in being right and being the entity that puts forward the right solution. Now, these capabilities are relevant in a broad range of situations where the safety of a complex system involves behavioural or social as well as technical components. So just to conclude, I've included a quote here from one of our case study interviewees, who was responsible for decision making in one of the local council areas, just highlighting the fact that the recognition that flooding is a part of their way of life, and it's unaffordable, despite people promising that it might happen. It's unaffordable to build their way out of floods, and that they need to work in other ways with the communities to help reduce the impact of these events. So thanks for your time. It's been great to be part of the Safer Complex Systems program, and I look forward to its next phases.
Hello, everybody. My name is Brian Collins. I'm the Emeritus Professor of Engineering Policy at University College London, but more importantly, I had the privilege of chairing the Case Study Steering Committee. And what we're going to do now for half an hour is, with my 3 colleagues who are on this call with me, Laura, Chris and Richard, discuss what their view was of the principal findings that came out of these studies. So I'll get them to introduce themselves in a moment, and we'll build on what you've heard from the studies that you've just seen presentations on, and indeed what Dame Judith said at the outset. So one of the things that we were quite surprised was to see how rich the findings were. Some of them were not too surprising, but actually the similarity of findings from each of the sectors that were reviewed was enlightening, at least. And I would like to echo what Dame Judith said about governance, especially the governance issue in the design phase of large projects. And the carrying through of those principles of governance through the lifetime was something that we found to be significant, and in some cases quite a weakness of some of the activities that we reviewed. So I'm now going to start by asking each of my 3 colleagues to give their views on what they have found, not only from the studies they were involved in, but the complete set of studies, which when you've got the stamina to download a 200-page report, when it becomes available soon, you will be able to see the detail behind all of that. And then we'll ask for Q&A, and will you please use the chat function to put your questions in, and they will be fed to me, and I will select those accordingly. So I'm going to start, if I may, with Chris, and ask him to introduce himself and then say a little bit about what his reflections are. So over to you, Chris.
Thanks very much, Chairman. Yes, good afternoon. I'm Chris Elliott. The relevant point here is I'm a barrister as well as an engineer. So I work very much in regulated engineering, safety, and so on. I'm currently working in medical devices. I'm going to say just a little bit about a study that I chucked into the mix because it highlights two things. It's a very stark example of a system failure, and also it highlights a lot of the problems in the law concerned with systems. This was a rail accident that occurred after UK privatisation. And I should just say now, you may remember over 20 years ago, the screaming headlines about privatised railway was not safe. They were not true. The railway was safer after privatisation than before. But there were still accidents, and this one occurred for a very complex reason. It's arguable it would not have happened at all if there hadn't been 3 independent failures by 3 different parts of the system. So at one level, there you are, there's Jim Reason's Swiss cheese, where the holes lined up and the train crashed. But if you look a bit more deeply, you can see some of the legal issues emerged. What we had done was take what was previously an integrated system, British Rail, and we broke it up. And we gave each of the functions to a contractor, a company, by contract. Now, each of the functions was covered. What we didn't do was manage the interfaces between those functions. So what we see really is a failure in the way that the legal process set the contracts. But that sort of points to a more general set of issues. But in civil law, I mean, the really big issue is everything to do with the law of tort, which underpins negligence. It relies on the concept of causation. And in this example, there would be no attributable causation because of the multiple causes. We have a similar problem in the criminal law. It relies on intent, unless it's a special case, normally on intent, but also proof that the person did what they're accused of beyond reasonable doubt. So you start having multiple causes and possibly statistical events coming in, you cannot realistically expect the criminal law to apply. And in fact, in the UK, we rely on the Health and Safety at Work Act to apply safety in the criminal law. That was never intended to apply to complex systems like transport, expressly in the report, the Robins report that led to that law. So we've got a legal framework built on sand trying to regulate complex systems. But my more general message that came out of looking at this and the other studies, if we want to use market-based mechanisms to deliver safety critical systems, we have to manage the interfaces as well as the components. Thank you, Chairman. I'll stop there.
Thank you, Chris. That's very much to the point and very useful. I'm sure it will stimulate some reaction. If I can now pass over to Laura and ask her to introduce herself and talk to her study and her general reflections on the studies as a whole.
Yeah, thank you. Hi, I'm a doctoral researcher at the Global Development Institute at the University of Manchester, researching fire risk and informal settlements in Nairobi. And I'm part of the kindling team that carried out a comparative study of fire risk emergence in informal settlements in Dhaka and Cape Town. Our work set out to understand fire risk as emerging from complex urban systems. And I'm just going to briefly talk about some of the disconnects that we found between bottom-up and top-down approaches to the problem. So in our research, we followed a process of first trying to understand how and why people and places are made vulnerable and exposed to hazards via social, economic and political processes. And firstly, this allowed us to identify the disconnects between the root causes and the progression of fire risk and the appropriateness and the relevance of safety systems as actually practiced. And mapping out these risk emergence routes helps us to identify new knowledge and entry points for different stakeholders to understand the issues better and try and encourage better coordination efforts for safety. Overall, we found that the safety approaches weren't tackling these root causes. which were rooted in urban structural inequalities. And both bottom-up and top-down approaches were very much hazard reactive as opposed to tackling those underlying risk processes. Broadly, bottom-up approaches, that is those that were engaged in and led by residents in preparing and responding and recovering from fire, weren't integrated, considered, and were often misrecognised by other actors, such as fire services. And broadly, people's lived experiences, their knowledges, their priorities were often excluded from broader conversations about developing solutions, despite their central role in actually implementing fire safety on the ground. Top-down approaches, such as command and control safety systems designed for formally planned areas of cities, were often extended to informal settlements, but were inappropriate for the actual context of informal communities. The fundamental assumptions that underpin their success generally didn't apply in informal contexts, and minimise the role of the public in protecting themselves from fire. So inappropriate sort of responses which weren't reflective of the reality on the ground. And again, more broadly, there was a lack of oversight, communication, coordination between relevant actors, meaning they're often acting in silos and with incomplete information. And this kind of relates back to a lack of effective and inclusive governance and governance at the urban level, and then which then sort of feeds into ineffective, inappropriate responses and creating this feedback loop of contributing to sort of more and increased fire risk emergence. So a key issue therefore for us was recognition and engagement with the full range of actors involved in the system, recognising their diversity, their location and role within the system, power relations between them, and the actual roles and responsibilities that they perform, whether designated or not. And we felt that this would help counter the disconnect between the bottom-up and top-down approaches revealed in our research, and specifically the exclusion of low-income residents in areas of the city from conversations about fire safety, despite the disproportionate risk that they face. So yeah, we sort of support a supporting an enabling approach that recognises that communities and residents must be worked with and centred to inform holistic fire safety solutions that navigate local barriers and leverage resources. Resourcing on this issue is obviously a big issue, particularly in the context of cities in low to middle income countries. But a step change in this approach we feel is urgently needed to avoid catastrophic losses. And for us, the nature of fire risk within a complex system, and I think for many of the case studies, means that there isn't a straightforward list of interventions that can be applied, and that ultimately to sort of improve safety in these contexts, deep systemic and structural changes are needed in urban development, tenure security, housing and energy provision, and that these are long-term and enduring challenges, but must be understood and worked with through the sort of by clearly understanding and trying to nurture these connections between top-down and bottom-up approaches, ultimately to affect just and equal safety outcomes.
Nora, thank you very much for that exposition of your findings. Brilliant. Could I remind people on the webinar that if they would like to ask the panel questions, please put them in the chat within the next 5 minutes or so, because that's the time period we've got for pulling them together and see what else we can discover that could be of interest to you. So I'll pass over now to Richard and ask him to introduce himself and also to talk about his findings from his own study and the general view. Richard.
Thank you very much indeed, Brian. Well, I'm Dr. Dick Taylor. I'm visiting professor at the University of Bristol in the Safety Systems Research Centre. My background includes being a corporate head of safety and environment in the nuclear industry. And more recently, I've carried out consultancy work on strategic safety matters and also spent 3 or 4 years as a non-executive director of the Health and Safety Executive. I'm part of a team from Bristol and Bath universities who've been carrying out work on looking at the organizational and cultural precursors to disasters, across a wide range of industries, including petrochemical, nuclear, transport, and major civil engineering projects. And in understanding these, as I'll say in a moment, we found some rather interesting commonalities. We've carried out 2 very major studies recently, which have been funded by the UK Energy Institute, for which we're very grateful. And these have been summarized in our paper, Improving Resilience to Major Safety Events by Analysing Case Studies, which not only provides a summary of those findings, but also proposes some actions which might be taken to try to improve resilience in the sorts of systems that we've been studying. I'd like to draw out 3 points from our study, and the more I hear of the current programme of work, many of them seem to be commonalities in some of the other research that's being carried out. Firstly, we have found, as I said earlier, very significant commonalities in the organisational and cultural precursors to the events that we've studied. These included sort of significant shortcomings in areas already been mentioned, like governance and leadership, in impact of commercial pressures, which is sometimes not fully taken into account, the pressures that these cause people to take shortcuts and so on. In safety culture, which perhaps is not surprising, and in learning from previous events, or perhaps I ought to say in an inability to learn from previous events, and sometimes again neglected, but very important, failings in oversight and scrutiny, people checking for an organisation or a group of organisations that reality actually aligns with expectations. So commonality was something that we found. The second, I think, important and I think in some ways a little surprising to us when we started this work was the fundamental importance of taking into account behavioural factors in both understanding complex systems and designing effective interventions. And in our Bath Bristol study, we've had the great benefit of having a psychologist, Andy Wayman from the University of Bath, involved. And this has allowed us, I think, to draw together some of those broader perspectives. And I'm convinced that it's very important that we sort of fuse system engineering and social science thinking in trying to get to grips with some of these things. Thirdly, in developing strategies to try and improve resilience in the complex systems that we've looked at, and I'm sure that I feel this is true probably of some of the others, it's very necessary to develop what I call a participative systems approach. And by that I mean that when one's trying to come to an understanding of the systems, and particularly in trying to seek actions which can improve resilience to failure, I think it's, and associated performance indicators as well for the future, I think it's very important that there's a sort of open-minded approach to try to find actions that will not lead to knock-on effects, undesirable knock-on effects. And certainly we've found, and we've given examples in our paper of how this can potentially happen. And in our paper, we've also given an approach which we think is fundamentally of quite considerable value, called causal loop diagrams, a systems engineering approach, which enables various stakeholders, various people within an organization who may have different views and different experiences, to come together and look at actions which are proposed, to rehearse them through these causal loop diagrams, and then make sure that they won't lead to those unintended consequences. So there are 3 things that I wanted particularly to draw out. But I think that what we've tried to do, begun to do, and this needs to be proven, but we've been trialing an approach which provides 3 steps to improving resilience. And I'm hoping that we could demonstrate this more effectively on other systems. We've looked at the 12 events, but I think it would be of great interest to see how broadly that can be applied and how particularly it can be brought together with the very useful University of York framework, which Judith Hackett mentioned at the start of today's proceedings. So that concludes my remarks, Chairman. Thank you very much.
Thank you, Richard. That's very helpful. And having prompted you to produce questions for us, you've delivered a cascade of them, which is brilliant. Thank you very much indeed. And I'm going to cherry pick a few and point them, and they have no notice this is coming to them. First of all, Chris, actually, a question of to what extent you think the intrinsic nature of a blame culture exists in some sectors, which of course has a litigation and legal context. How much is that a factor, and how could we address it?
That's the third theme I didn't pick up in my brief overview. The whole concept of accident investigation. The reason why it is so safe to fly in an aeroplane is because we've had a culture from the start of civil aviation that investigates accidents with the intent of finding cause, not blame. And there's a tension between the two. In the aviation domain, we have a very strict legal framework that says that evidence presented to the accident investigator cannot be used in subsequent criminal or civil proceedings. It means that people are free to talk. We have a slightly weaker version in the marine world and an even weaker version for railways. And when you get to something like roads, the accident investigator is the policeman. So accident investigation is absolutely crucial, and it has to be. If we're going to prevent accidents recurring, rather than punish the guy who caused this one, then we have to get away from looking for blame and say, why did this happen? And more importantly, how do we stop it happening again? And our blame culture makes that very hard to do.
Thank you, Chris. I mean, that's, I think, reinforcing that we do need to interact process and engineering methods with social and legal processes. And that brings me actually to a slightly different stance on that, and a question for Laura, which is in the contexts in which you have worked, there will be predispositions of how you're going to deal with these sorts of episodes were they to occur. And yet those predispositions may be based on false assumptions, unverified assumptions, as Jane Judith mentioned in her introduction, an important factor that's come out generally. To what extent do you think that predisposition of how are we going to deal with this actually gets in the way of dealing with a situation were it to arrive?
Yeah, well, I think in our case of looking at fire and informal settlements, one of the key sort of barriers that we're coming up against is people's attitudes to these areas and attitudes to people living in those areas. And again, I guess a bit related to the issue of blame, but blame is sort of by fire services and the kind of from a more institutional level put firmly at the door of people living in these conditions in poverty without sort of understanding the wider context of how that risk has come about through various unjust urban processes. And yeah, that absolutely affects the way in which, especially in my research, that fire responders respond to these situations, so often not even attending in the first place, and sort of falling back on sort of stereotypes yeah, I guess false understandings of how fires start in the first place. So I think, yeah, tackling attitudes, especially towards sort of more marginalised parts of society, is a huge issue, and the complexity of those interactions, which sometimes goes both ways, yeah, is hugely important in understanding and implementing safety in complex systems.
Thank you, Laura. I'm going to pick up a bunch of questions which are to do with digital and AI and machine learning and information sharing, all of which are sort of coupled together. One of the things we noticed during the lifetime of this work was the growth in not only AI and machine learning, but its prevalence and spread throughout almost every sector that we were looking at. But in addition, the difficulty we had with regard to the ethics of that, with regard to its availability and its impact on various communities, and whether there were biases that were being put in to machine learning in particular through how machine learning systems were being created. One of the things we have thought about, and you'll see it in the report, is a request to anyone who reads the report right to the end for suggestions for further work, and there are places to navigate those requests to. And this is one area that we think is certainly not well enough studied yet. The impact of AI, machine learning, information sharing, and the Internet of Things, which of course provides sensors and sensing to a much greater density and a much greater clarity going forward, which may or may not help with regards to safety. It ought to help if it's organised and looked after properly, but it may in fact not do so. So there's an issue there, which, and thank you for the many people who ask those sorts of questions, because that is, we think, one of the areas that we haven't studied enough yet. And it in itself is, as you well appreciate, quite complex. I mentioned something to do with governance earlier, and I think the whole issue of governance is also sparked some questions. So Richard, I'm going to come to you and say, so if we're going to revamp the thinking around governance and how we interact with business schools and with other communities who teach governance, and you and I both come from university as well, how are we going to do that? How are we going to implement thinking more holistically and more sustainably about governance of safety in the way in which we do university education, but also professional development and consultancy, because the consultants have quite an impact in this area. So Richard, could you say something about that, please?
Yes, I mean, it's quite a difficult question, and I would put together sort of governance, they're not entirely the same, with the whole concept of leadership, which we've looked at in our study, for example. I think the first thing is that leaders as well have to be clear about learning from previous events. And I think that we need to make sure that leaders and people who are involved in governance have that full appreciation of some of the factors which have led to earlier events, not only in their sector, but more widely, because one of the things we found was that because those precursors were across a whole range of industries, it does actually mean that if you could find better ways of dealing with them, that commonality could extend across a range of industries, not just simply the industry in question. And so I think number one on that is making sure that people actually understand the importance of getting that broader learning. The other thing I think is that we should be making it available to leaders to try to develop and think themselves through some of the issues around their expectations. So in many, many cases, you know, industries publish corporate expectations. From my experience, you know, that's not always something that the leaders themselves are fully engaged with and fully understand. And I think it's important that, you know, leaders do actually engage with that, do understand the whole range of issues which they expect of their workforce and their teams. And I didn't mention earlier, others have mentioned this vital question of interface with and between contractors and the leadership role in making sure that governance make sure that those interactions and the communication issues are dealt with very effectively. So for me, you know, two issues there, and it obviously goes beyond that, but I think it's a fundamental and sort of vital first step to make sure that those things are in place.
Thank you, Richard. I'd like to just amplify myself one element of what you just touched on, which is the continuity of leadership. Yeah. All too often with the very large critical infrastructure programs that we see that maybe take 5, 10, even 15 years to complete, the chances of the people who end up running things at the end being the same as those who were starting it is very small. So that means unless there is a continuity of corporate memory, which is quite difficult to sustain at a level of detail that's needed in order to deliver the safety regimes that we expect these systems to have, then it is in itself a complex system of management, which it needs to be addressed in the way in which the governance of the whole program, if I can use the word stewardship perhaps as rather than governance, because governance is a little bit close to the practicality, the stewardship of the principles which will be used right the way through an activity of that scale and length and duration, I think is an important issue. And I don't know that we see clearly who owns the principles of that being something that will be necessary. Maybe it is combinations of the Academy of Engineering and other academies and other bodies who have an interest. But that in itself is a convening process, which is, Dame Judith said in her introduction, we are very interested in convening communities that, as it were, have skin in the game to deliver much better outcomes, to make the situation better. And that is something that we need to consider, is how, do we need different stewardship models as well as different governance models? Richard, you've got your hand up if you want to add something to what I just said.
Yeah, it's very interesting you should say that, Brian, because in our most recent piece of work funded by the Energy Institute, this is just one of the systems that we've actually looked at. And we've used causal loop diagrams to try to get to grips with some of those issues around the continuity of leadership and the failures that can lead to. So I couldn't agree more with what you've just said.
It actually it reflects back on something Chris said about the blame culture too, which is you can actually almost institutionalize organized forgetfulness in order to be sure that you don't have the evidence later in the state in an activity which shows whether or not something was looked after properly. And well, that's probably not something to talk about, especially today, given other reports that have been published today. So I think there is something to do with ensuring that the information sharing through the lifetime of a project, not only that, between sectors and between communities, which we talked about more earlier in this session, that continuity of availability of principles and how things were designed to work, and then discover 15 years later, oh, that was how it was designed to work. That's different from how we've actually got it. I don't see any new questions that we've arrived, and hopefully I've managed to cover the ones that we did get. And if you find that actually that hasn't happened, I'll repeat what I said earlier and Dame Judith said right at the beginning. The report contains the navigation information for how you get back to both Lloyd's Register and to the Royal Academy of Engineering for further inputs. We would be delighted to have further inputs from anyone on this call or anyone not on this call, but you think should have been, and get them to offer their inputs to us with regard to what this programme should consider going forward. So unless my colleagues on the panel have anything further to say, and I don't see them raising their hands, I'm going to suggest that that is where we finish this webinar. Thank you all very much for attending, and I hope you found it useful. Good luck reading the report. It is a lot of material in there. It itself is quite complex, but it does represent 18 months of very valuable work, and I think is a body of knowledge that bears scrutiny for those of you who are involved in safety and complex safe systems, and will hopefully improve the situation for all of us who are involved in complexity. Thank you very much indeed.